Hi, everyone. Welcome back from our short break. Today I have the pleasure of introducing Sadish Karunaweera from the chemistry department. Sadish is their laboratory administrator, which means he's a safety officer and a chemist at K-State. Besides working as a safety officer, he teaches safe chemical laboratory practices as an associate graduate faculty member. Sadish completed his bachelor's degree in physical sciences in 2006 and master's degree in analytical chemistry in 2008 from the University of. He came to K-State in 2010 as a graduate student and completed his PhD in physical chemistry in 2016. After graduating from K-State, he continued research until 2018 as a postdoctoral research associate. In the meantime, he worked as an adjunct instructor at Highland Community College in Wamego in 2017 as an instructor at Emporia State, and then in 2018 and 2019 as an instructor at Emporia State University. After that, he joined K-State Chemistry Department in 2020 as an instructor, and in 2021, he joined Dybul Laboratories of Kansas here in town as their chemistry manager. After working there for about 1.5 years, he came back to the K-State Chemistry Department to accept his current position. Now I'm going to hand it over to Sadish now.
Thank you, Rachel, for the kind introduction. All right. So I'm going to talk about the chemical safety and integrating it to the curriculum. So this will be my outline for today. First, let's look at the basic, like the equipment in a chemistry lab. So we have the fire extinguisher, and then first aid kit, the fire blanket in case of a fire to be used. Then we have the safety showers and the IO stations, and also the fume hoods. Those are the main safety equipment in a chemistry lab. So when you are using the fume hood, the sash has to be closed when not in use. So if you are doing an experiment, and so you'll have to have access to the fume hood. As soon as you are done, the sash should be closed. Otherwise, the fume hood won't serve the purpose. And there should not be any paper towels or excessive equipment inside, because you need to have space. The reason not to have paper towels is, so it's sucking in. So if the paper towels are in there, they can get sucked in and the fume hood can get clogged. So you'll have to have maintenance come and fix that for you. Okay. And of course, we will not use it as a storage place for the chemicals. You can have the chemicals for a reaction that you are doing, but not in long run. Then let's talk about, so we will be dealing with chemicals in a chemistry lab. So the ways that we can have exposure to the chemicals. There are 4 different ways: inhalation, absorption, and injection. Inhalation, absorption, and injection, which is through skin contact, and ingestion. Then let's briefly talk about what those means. So the first thing is the inhalation, and it is the most likeliest route of exposure to chemicals, because you can inhale things without notice. So there are gases in labs, and dusts, chemical vapors, and fumes in a chemistry lab. So in case of inhalation, to prevent the inhalations, these are the preventive measures that you can take. Use a fume hood. That's the safest way to get rid of the chemical vapors and all the chemicals. If they are handled inside the hood, whatever the vapors coming out from the chemicals will be sucked in, so you won't get exposed. And cover all your containers containing chemicals. So once they are sealed, once they are covered with parafilm or like some form of covering, will prevent you from inhaling those chemicals. and of course, wear PPE or the masks. So there are two types through skin contact. The first is absorption. So whenever you enter a chemistry lab, we have to have some kind of PPE if you are going to work there. And if you are just visiting, it may be okay, but again, so there will be signs posted on the door, like when you enter a lab. So please, before you go in, please make sure you pay attention to whatever the signs are there. Okay. So generally speaking, for our teaching labs and research labs, we have a lab coat, which is to protect you from chemical contaminations, and safety glasses to protect your eyes. And if you are dealing with hazardous chemicals, of course, you have to wear gloves as well. And recently, we introduced a special lab coat, type of lab coats, which are called the flame-resistant lab coats for the type of work that you perform in a lab. So, for example, all the professors in the chemistry department did not go to that option, because if you don't do any work related to fire hazards, then you don't need that. Standard lab coat will be good enough in that case. But if you are dealing with fire hazards, then those professors decided to upgrade their lab coats to the flame-resistant lab coats. So when talking back again about the absorption, it can cause anything from slight irritation to permanent damage. So we have to be careful. And the preventive measures which we can take are, of course, dress properly when you go to a lab and wear your PPE, as we discussed already. So these are not proper clothing to work in a lab. Your hair should be tied back always. So there is this misconception that students always, so I go during our teaching labs. With kids, it's sometimes it's difficult, but with graduate students and researchers, they understand because they have been in the labs for a couple of years. At least they know what to expect. But college kids right from the high school, they don't, sometimes they look at me at mad, right? But then I explain them the importance of the safety. So if I talk to them in a kind way, explain them the consequences, then they understand. So first thing I'll got, of course, it is not convenient to have the safety glasses all the time, because especially if you're having glasses like me, it fogs you sometimes, depending on the weather condition. So whenever I go to a lab, I see at least one or two kids not wearing the safety glasses. So the first thing I would say, point at them, is to wear the glasses. And then I will explain that, of course, it is not convenient, but what if something happens? What if something goes into your eyes? As long as things go smoothly, no one will complain. But if there's something, so we have come across incidents, right? So there have been, for example, in the fall of 2022, just before I joined the department, in an organic teaching lab, there was an incident where some sulfuric acid sneaked through the glove, and it caused the skin to burn. So initially, the student was not, so the thing which happened was they were using a SEP funnel for the experiment in that day. So when they inverted it, it was not properly sealed and it sneaked through and went inside the glove and burned the skin. So rather than having those situations, it's always better to take the safe protocols. So that's why we always encourage safety first at all costs in our labs.
We need to respect the social dynamics of that side, that common face of the world. But if they want to go in lab on their attire, they can the lab footage, they can still.
No, I mean, if they are in show, I mean, depending again, like say we have some dry labs. So if there are no chemicals, we'll use common sense in that case. So for example, last week, we did not use any wet chemistry in our Chem 1 lab. It was like building models and stuff. So for that, we can let them in because there is no chemicals. It's true that you may be, so for example, we have a lab where we use sodium chloride, which is salt, table salt, right? So although we will not be using hazardous chemicals, we still can have broken glass. Say if a glass break, and if you are in shorts, because the lab coat will not cover your up to the feet, right? So if when the glass is broken, if a piece of glass hits your lower leg, then you're bound to take a cut. So the proper clothing is you should have a long pant to your ankle. And basically no skin should be visible from your neck to the ankle. You don't need long sleeves, but at least short sleeves, no cutoffs like this. So as I said, the other thing, what I was going to say is the hair. So hair should be tied back always. So there's this misconception among students that even some of our TAs, they think that hair should be tied back only when the flames, like the Bunsen burners or some kind of flames are in use, which is not true. Because in a chemistry lab, you are dealing with chemicals. So accidents can happen at any time. And if your hair is loose, when you are moving through the lab, it can get caught somewhere else too, not only with flames. So that is why it is important to have your hair tied back, then have the proper properly dressed from your neck to the toes, and then your feet should be covered with shoes as well. No sandals, no flip-flops or anything. And one other thing that we encourage students is, so see, like now it's getting warmer, so they may come in shorts by mistake. They may forget that they have a chemistry lab in the day, later in the day, so they may wear shorts. In our labs, we have the unique opportunity that each students get a drawer. So we encourage them to have a long pad in that drawer, so that in case if they come in shorts, then they don't need to go back. They can just go to a restroom and change their long pads. And then have the lab coat on top of that to protect you from the contaminations. Are we good on that? Any more questions?
So if they're not dressed appropriately,
Depending on the labs. I will, I want to be like that, but again, then, we have to respect the students too, because they pay tuition. I don't want them to go home if there is, so for example, last week, because we are not using any chemicals, then depending on the lab, I will excuse them. But we have our lab safety agreement, and it clearly says that if you are not properly dressed, you can be sent home, and it is up to you to come back. Again, there are 3-hour labs, mainly the low-level lab classes. So in case if you have to leave, you won't get that extra time back, because once your lab is done, there is another class coming after that. So we make it clear on the very first day when they do the lab check-in, so that they'll be sent home if they are not properly dressed. So the departmental policy is, Chem 1, it is the most populated class in our department, I guess, maybe throughout the university, because most students take Chem 1. So for example, we had 4,000 students for Chem 1 last semester, and they can drop 2 labs. So if they are to, we'll ask them to drop the first 2 classes regardless of whatever they are doing. Regardless of the reason. So they'll drop the first 2 labs, and then we will, depending on the third, then when the third miss comes on, depending on the legibility, we'll allow them to reschedule. Otherwise, with the large number of student population, it is hard on us to accommodate that. Okay. All right. So we don't have anything as of now. We may, again, like, so that's a good question, because when you are wearing the gloves, if you have a ring, it can get damaged. I joined the department about 15 months ago, so I'm still getting used to the things, because I was in the department, but I took this role 15 months ago, so I'm trying to get the things organized. So we may come to that some point, but nothing as of now. That's a good point. Yeah. So the second way of exposure through skin is injection. So dealing with sharp objects, needles, broken glass, or razor or blades. Then the final route of exposure is ingestion. Of course, no food is allowed in the labs, especially in the chemistry labs. So this exposure is susceptible if you have food in the lab. So if you don't eat, smoke, or chew gum, drink any drinks, then there won't be this hazard in the lab. So when they enter the lab, all their food should be in their backpack. Yeah, everything should be in their backpack. Nothing visible, like nothing on the lab benches, lab tables. Everything in their backpacks. And of course, if they need to drink or have some snack, they are welcome to go outside the lab, eat, drink, and come back. But nothing inside the lab for the safety. All right, so let's move on. We're trying to go green with everything, right? So why not go green with chemistry? Again, to protect our environment, to protect us, protect everything, right? Go green as wherever possible. So to address that, design the products or processes or reactions that reduce or eliminate the use of and generation of hazardous substances. If there's the possibility, so these are the things that you can implement in your lab to promote green chemistry. Prevent or minimize the waste, and micro-scale work and elimination of wet chemistry is possible. Say like you are starting a reaction which involves hazardous chemicals. You can, like, now there are like computer simulations, if possible. For example, our department has 2 computational chemists. So you can contact a computational chemist to see whether that reaction is feasible before you, of course, you will spend some money to buy chemicals, and then if they are hazardous, if they generate hazardous waste, then you'll have to deal with hazardous waste too. So why not, if you're not sure about the reaction, whether it will work or not, first try to simulate to see whether it gives some background information. Then you can do microscale to start with. And then once you have a feel for the reaction, then you can go to whatever the bulk work. Of course, use safer materials. Then design experimental products for degradation after use whenever possible. I know those may not be relevant all the times, but if possible, these are the things that we can do. And real-time controls to prevent pollution. So if there is a waste generator, can we dispose it in a way without keeping it for a long time, which, like, if that gives a hazardous gas, which can cause some inhalation issues. So that's why the real-time controls to prevent pollution. Then minimize the potential of accidents. Avoid multi-hazardous waste generation. So there can be steps which can be followed for example, in a chemical synthesis, organic synthesis, if you can, there will be different routes that you can proceed through the end product. So that's what this means. Avoid multi-hazardous waste generation through different reaction pathways, if possible. Don't think we use any mercury in our labs anymore, but if there are ways to avoid that, then replace the mercury too. For example, some labs may still have the old mercury thermometers. So,
Stop doing those or
Yeah, absolutely. I think too, that's a good question on what do you have mercury right now? So I know they make some alternatives depending on what you're doing, and the green options are better, obviously. And I'm going to look to Brandon Chance in the back of the room, but we'd like to do a turn in your thermometer program. We talk initially behind the scenes, and so it's a amnesty day. Bring in your thermometers, and we'll give you money off towards replacement thermometers. Now, that is pending behind the scenes, but it's something that we'd like to do. If you look at the cost of when a thermometer breaks in the lab, splatters all over the place. You take the lab down, you take the hallway, so we would like to get rid of those. And so long term, also, if you have grants, you have funding, you're setting up a new lab, try to do those without the mercury containing devices. Always, yes. And I'm catching Brandon off guard here, but we're looking at how many in the past we've also gotten rid of, disposal cost, and trying to present that to management on why that's a good idea. And I think you'll see something in 2024.
because either you're waiting for that.
all right. So we started with working, like going into the lab. Then we talked about chemicals. So before you buy or like work with any chemicals, this is the first place where you will go, the safety data sheets. So this, the safety data sheet for a particular chemical will provide all these important details. The hazards of that chemical, physical and chemical properties, stability and reactivity, first aid measures in case of an accident, and handling and storage, what PPE is required to deal with when dealing with that chemical. So this is the most important thing for before you deal with the chemical. So once you have those, like you have your lab, you have your knowledge, proper knowledge for the chemical that you are going to purchase, then you're going to order the chemicals. So the ordering, again, if it's a research lab or a teaching lab, have a designated person to order the chemical. And so if there are multiple people ordering the chemical, they can have the repetitions. Say it's a hazardous chemical, there's no point of having the same hazardous chemical ordered multiple times. And by having a designated person to do the ordering, you can prevent that. And of course, before you order, ask these questions all the time. What is the availability of those chemicals? And what is the minimum amount you need? Say like you may not need 100 grams of that chemical. If it's needed only, although it may be cheap to buy the 100 grams, if you need only 1 gram of that chemical, why buy 99 more grams, although it's cheap? And you may still have to pay, like spend extra time, you'll have to contact EHS, you'll have to submit the waste pickup request. I mean, if the chemical needs special handling, even the EHS will have to hire professionals to get rid of that. I mean, I have the experiences, so that's why I'm talking. So please think about all these facts before you purchase a chemical. And so we talked about this, the size of the container. So there will be limits based on the class of the chemical, to be stored in a particular lab. So pay attention to that as well. And of course, whether the chemical is stable and can waste be managed. If you are not sure about, like, after going through the SDS, if you still have questions, the best people would be to reach out to the EHS. Then they'll let you know. So for example, sometimes they may not be able to dispose the chemical right away if you contact them. So that's why it's important whether the waste can be managed. So once the ordering is done, you will receive the chemicals. There are some important steps involved with that too. So all our chemicals will be delivered to the chemistry store. I'm sure you'll have proper receiving areas for in your respective departments. So once the chemical is received, then use the proper equipment to pick up the orders. I'll have more details later in the slides. So for example, you are never to carry a chemical by hand. Always use secondary containers, carts, or in case of a gas cylinder, use the cylinder carts. And it is important to check the package whenever it arrives, right? Sometimes it can get damaged during the shipment. So once you receive a package, always check whether it's in good shape. And some chemicals will have an expiration date. So by mistake, they may send you an expired chemical. So why you deal with the expired chemical once you pay for chemical. So check the date whenever necessary too. I know in most cases, the expiration will not matter, but there can be instances. So please pay attention to that as well. So you have the chemicals. Before you use the chemicals, it should be recorded in the chemical inventory. So the chemical inventory is a database that installs, which lists all the current chemicals in a particular laboratory. And you can include the essential information for the proper management of that chemical too. So these are the information which should be included in a chemical inventory. Name as printed on the container, not the formula. I mean, some people, so say you have your chemical inventory with formulas. All the people may not have the proper knowledge to read the chemical formula. So that is why it's important to print the name as explicitly as possible. And of course, there's no harm to have the formula, but not only the formula along with the name. And the cash registry number. So cash registry number is a unique number associated with each and every chemical. Where it came from, the manufacturer, the supplier, and the size of the container, 100 grams or 5 grams or whatever the size. Then what is the location in your lab that you can find it? The date which the chemical was received. All this information, when all this information is documented, it is quite easy to find a chemical. So in our department, all the PIs and the teaching labs does their inventory, and as the safety officer, I have all those inventory. So for some professors, if they start a new project, they may need a new chemical which they don't have in their lab. So they always come to me and ask me to check whether the chemical is in other labs in the department. That way, then you don't, again, this is associated with the hazards with chemicals, right? So if you want to try something new, you always can borrow a little bit of chemical if it's with the department, if it is available on campus. Then you can try your experiment, and then once you are sure that expected results are obtained, you can go ahead and order. So that if the inventories are not in place, then no one will be able to check. So it is very important once you acquire chemicals, they are included in the inventory. So it is a legal requirement as well. So we already discussed, so it is vital to the lab management and chemical tracking, promote the economical and sharing of chemicals, update the inventory every time when you use a chemical, or buy a new chemical. That is important too. Say like you get 100 grams when you order, and after the first use, you may be down to 50 grams, which is very important. This is very important in case of the teaching labs, because sometimes you use big amounts of chemical for a particular lab, and you don't need it till the next semester. So we have our student workers who are helping us with the teaching lab. I always tell them to let me know whenever they notice that when we are running out of a chemical. If you don't update your inventory, no one will be able to track those. So that's why it's important to keep track of what you have and if you need to order immediately. And at least do a complete chemical inventory annually. You go along as they come on day by day, but still you can miss something, right? So if you at least do a annual inventory, then you can plug those gaps. So the ways to reduce the chemical inventory. Consider disposing of chemicals that are not expected to be used within a reasonable time. Say you order chemical and you know that you won't be able to use it for a while. You can share it with your colleagues, right? Before it gets expired. So someone else can use that, which makes the job of the EHS easier too, because then they won't have to worry about disposing all those chemicals once they are expired without no one being using it. Inspect and handle the deteriorating containers or with evidences of chemical change inside. So although the chemicals will be in good shape whenever they come in, they can get bad with time. So always it is important to check the condition of your chemicals and dispose or recycle chemicals before expiration. And once a chemical leaks or like with time, the labels may fade off or they may come off from the bottle. So it is important to replace the deteriorating labels and clean all hazard chemicals. Transfer when the laboratory is closed. So say like if a PI is leaving, retiring or leaving to a different institution, you can always transfer those chemicals to a different group in the department. All right, are we doing good? Any questions so far?
Inventory is worse than
Yes, I mean, in a way, safety too, but mainly it's the management, so that you don't have like multiple order. It can prevent multiple ordering. Like you can share the chemicals among the groups in the department. Yeah.
Where should be its location? Everybody in the group should have access to it.
Yes. So I think the easiest way would be the electronic version. So if you can have I have the electronic, otherwise it's hard for me. Hard copies, it will be hard for me to track down. So that's why the CAS number is important too. Whenever you build your inventory, if you have the CAS number listed, usually I search by the CAS number because it's a unique number. You had a question?
Are you labeling your chemicals as to when they come in? Do you actually do that on the bottle, or do you just do it in the inventory? Do you put a date, a date that you bought it?
Yeah.
In the inventory, do you put anything on the container?
No, okay. Only on because the inventory has the location and all the details. So I'll talk about it later about the storage. So we have to have the compatible chemicals together. So since at least in the chemistry department, that's what we do. So since we have the designated areas for those different classes, we don't put a date on the label. There may be instances that you may have to put, say like some chemicals may get bad once they are open original. If that is the case, of course, we'll have a note on the bottle. But in general, we don't have any notes on the bottle with the date.
Do you have a mandatory disposal time period, or does it depend upon Also, you get a chemical in today,
uh,
do you get rid of it mandatory in 5 years, or do you just look for an expiration date, expect expiration date?
yeah, depending on the chemicals. Yeah, there's no like strict rule regarding the disposal.
I think some of the departments have gone to, it comes in today, say in 5 years, it has to be gone.
Okay.
Even that should be guided by the data set, right?
Mhm. Yeah.
Regards to the involved process.
Yeah. That's yeah. So in general, we don't, but depending on the chemicals, we do that. Yeah. So the labeling of chemicals. So commercially packaged chemicals don't remove or defactor any existing labels on the incoming containers. Leave the original labels all the time. So it gives you the chemical identity, manufacturer identity, hazard pictogram, signal words, hazard statements, precautions, and first aid information. So all those are in the original label. So never get rid of those. And some chemicals will be synthesized in a lab using the ingredients. So you'll have to come up with a labeling system for such chemicals. So this is one example that you can do. Name of the researcher, then the reference number, and any other relevant information. So this is the sample example I have, the name of the researcher, the lab notebook number, and then the page number and the compound number. Some kind of unique labeling system for your group, research group, or whatever the group you are working with, so that you are able to identify a particular chemical. Again, this is an issue that we faced when we are cleaning up some of the vacated labs in our department. There were chemicals, some did not have any labels, and some had like structures. Even as a chemist for like 20 years, even I don't know some, right? So it is important to have the labels created properly that anyone can, provide as much details as possible, because one day you may be gone once those chemicals are being disposed. So the more information, the easier it is for the others to deal with.
So people make NaCl solution,
Any,
sodium chloride solution. On that solution also,
yes, because it's colorless, right? It can be anything. It can be water. It can be like concentrated acid, because all the acids are colorless. So regardless of the chemical, even if it's water, because you might be working and you may leave for the lunch, right? And there can be an accident while you are gone. Say like EHS or the emergency personnel comes in to help, and there is this bottle or beaker full with a colorless solution. No one knows what it is, right? So that is why the labeling is important all the time. You have to accept that anything can happen when you are not, we know that what you will be, if I am the one who is doing the experiment, I know what it is, but I may not be there when an accident happens. So that is why it is important to have the labels properly so that anyone can recognize what is that chemical.
or we can even notice that work is going on, done, something.
Still the label matters, right? Although you have the note, it does not guarantee that you don't need to know the chemical, right? Say if the work is going on and if there is a fire, so emergency personnel will need to enter the lab to evacuate the fire, right? So that's why the labeling is important. Then the storage of chemical. So again, you have to consider different aspects with the storage of chemicals. Avoid storing on high shells. So like if it's above you, they are susceptible to fall. Shells must have a lip at the front edge. Sorry, I forgot to take a picture for that. So like if you are storing chemicals on a shell, there should be a small lip to prevent the falling over of those chemicals. Then store heavy containers on lower shelves. Again, this may not be possible with the compatibility issues, but if possible, try to rearrange your chemicals such that the heavy containers are on the bottom shelves. That way, this hazard is taken away. Keep exits, pathways, and emergency equipment areas free of storage. And there should not be any chemicals stored in fume hoods or floors. Designate definite storage areas for different types of chemicals. Separate chemicals into compatibility groups and store alphabetically within the groups, which helps you to find chemicals easy. And use secondary containers whenever necessary. So in case of a spill, in case if a bottle leaks with time, if you have it in a secondary container, it traps those chemicals spreading around. Then the classification for storing chemicals. Again, main thing would be the compatibility. You have to consider which chemicals can be stored together. So for example, store fuel away from oxidizers, open flames, and heat sources. They should be, because fuel can catch fire easily, right? And keep chemical groups separated by using secondary containers, cabinets, or distance. These are the class of chemicals, oxidizers, including peroxide. The color code is yellow. Corrosives and inorganic acids, gray. Corrosives, inorganic bases, excluding oxidizers or combustibles, are gray too. Flammables in red. Toxic, reproductive chemicals, and carcinogens, the blue. This is an example of storing chemical. So you may not have, obviously space can be an issue, right? So although you have to separate the chemicals by the classes, if the space is a problem, you may have to combine some of those. So this is an example. So compatible bases, compatible organic acids, not intrinsically reactive or flammable or combustibles, and non-reactive flammable and combustible, including solvents, can be stored together if needed, if the space is an issue. So, however, there are classes which should not be stored together. For example, incompatible with the chemicals which are incompatible with all other storage group should be kept separate all the time. And there are some chemicals which needs to be stored in refrigerators. Still, you have to have approved refrigerators. Like, for example, spark-free, explosive-proof, depending on the chemicals that you will be storing. And this is important too. There should be signs saying no food or lab chemical, no food since it is lab chemical storage, since the refrigerator is only for lab chemical storage. And you, again, inside the refrigerators, use secondary containers as needed. Still, the labeling matters. Label all materials with content, owner, date of acquisition, preparation, and potential hazards. All containers must be closed and stable. Everything which applies to storing applies to cold storage as well. These are some examples of incorrect cold storage. See, the labels are not labels are degraded, and this shouldn't be happening too. Yeah, all chemicals with leaks, and see this refrigerator should be disposed too, because it's not good to store the chemicals. Obvious corrosion.
Get those pictures from online.
These are some from our labs. Some may be from online too. I'm using a slide which was made previously. Yeah. Then storage of flammables and combustible liquids. This is what I mentioned earlier. So no more than 10 gallons of flammable liquids should be stored in cabinets. There are limits that you need to consider before you order. And keep away the oxidizers and ignition sources from the flammables.
Very contradictory statement. Nobody has educated me yet in the past 10 years or so. I oftentimes work with oxygen and ethylene. They are all the time going into my reactor. But I don't know how far these oxidizer and fuel should be there. Some people say 25 feet, but some people say put one into the fire rated box and other outside. So what is the path? What goes us in? Any idea on this?
Let's take a, you have an interesting lab. Let's take a look at your lab behind the scenes so I get a full visual. I don't want to mislead you, but yeah, you particularly have several NFPA, other guides in there as well. So we'll be visiting your lab.
So there's-
Your specific question, gallons. Are you questioning that if the max is 10 gallons? Are you, like the first bullet there, is your question?
My oxygen is here, acetylene is here. I need to work with these two gas. What is the process is I need to mix these gases and then into my reactor chamber. And then right now they are very close to each other because each of them have regulators and they have individual piping system. As long as I don't have any igniters around, I'm a physicist. I think it is still safe, but sometimes in the loose literatures, they have mentioned that they have to be 20 feet away, or one should be in the fire-rated cabinet, then you can make it close, something like that. So I personally want more of that because I have to work for many years in my future with this setup. That's why we have good knowledge is better.
Yeah, if you've got time this week, we'll be glad to stop by. I want a full visual, we can help you with that. You know, a lot of questions. Is it pressure rated? What's the total volume you're mixing, etc. A lot of questions I have in my brain before I answer.
Yeah, thank you. I want a full analysis from you guys and kind of improve more improvement.
Absolutely.
We are all the time welcoming persons. And require service.
Yeah.
So, argument for you, oxygen parts. There is, I think. If you do that reaction, you use. Specifically for not using
Yeah, and for our Zoom listeners, the question is oxidizers, flammables, and I think we're talking compressed gases, correct? So the normal NFPA and the normal storage is 20 feet apart, but you'll actually be amazed. You can put dry pulp up at just segregate that. So that's why I would more like to look at the operation itself. And there are barriers that you can have to put in place. But again, I would look at it from an overall risk management perspective and look at it closely and before we can give you that definite answer. So for those on Zoom call, the question is oxidizers, flammables, what are you going to do in the lab when you have that going to a reactor situation? So NFPA is a big one. Compressed gas association is another one that we'll be using behind the scenes to figure that out based on your operation. Good question.
So it is important to store the flammables in well-ventilated, cool and shaded places, because they can catch fire otherwise. Then the storing of gas cylinders. I have a couple of pictures after this. So securely strap or chain to a wall or bench top. They should not be left loose. And separate gas cylinder storage from other chemical storage. Again, segregate incompatibles, keep flammable gases away from reactives. And keep corrosives away from gas cylinders. And lecturate bottles are the small gas cylinders. Like whenever we say gas cylinders, what comes to our mind is the big ones, but there are small gas cylinders, pressurized, compressed ones if needed. And shipping caps should be used when transporting or not in use. And when not in use, if possible, shut the valves and relieve the pressure in the gas regulators. Remove the gas regulator and cap the cylinder so that they'll be kept away.
Here also, I think one point I want to point it out, university doesn't have any regulations on this probably. Maybe I don't know. Where should be these cylinders? In the open space or into the safe? Like saving from the raining, sunshine or snow, because that is what I think it is a good idea. That's why last year we renovated these gas cylinders place in our physics department. But I don't know, EHS has some rules on this.
Again, the question is indoor storage or external storage?
Yeah.
So it's external and internal both? Yeah, again, on that, that's going to go back to the Compressed Gas Association standards that you're not going to find a deep bench for regulations in OSHA. And again, what PSI is it under? Is it going into a bulk system? Is it individually feeding? You know, what's that plenum that it looks like? There's a lot of other specifications on your manifolds. Do you purge it at the end of the day or your experiment? You know, and how do you make sure that you won't have an accidental release? So you won't see a deep bench of information on OSHA on that, and that's why we'll go to NFPA and Compressed Gas Association. Same question. For our Zoom listeners, inside, outside, I think at the end of the day, contact EH&S will help you with the risk assessment. Another good question though.
So this is the proper way to store, like always chain them to a wall or to a lab bench. And these are the incorrect ways. See, these are not secured, so they can fall over. And although this is chained, it is loose. So the chaining should be tight so that it will not fall over or move. That's the whole purpose of securing it to the wall or to the lab bench. Then talking about storing highly reactive substances, I have the abbreviation HRS. So consider the storage requirement of each HRS prior to bringing them into the lab. Think ahead. And label the area. So have a designated area and put them in the designated area and have a label saying so that the others will be able to recognize. So something like danger, highly reactive material, or something along the lines. And only, so whenever you order only the required amount for immediate purpose. And do not force open a peroxide former if crystals are present, or it will not open free. So that's very important in case of peroxide formers. And check at least annually for degradation. Restrict the access to the storage areas, because highly reactive substances, so it's always better to keep the access restricted. Then storage of highly toxic substances, again, they should be ventilated, designated storage area in unbreakable, chemically resistant secondary containers. And keep quantities at a minimum working level. Again, a sign saying that caution or productive toxin storage. Limit the access to the storage area again, similar to the highly reactive chemicals. Then the transport of the chemicals. As I told you earlier, never hand carry the chemicals. Always use secondary container. In case of a spill, then the chemical will be contained. And use proper equipment such as lab carts or gas cylinder carts. And these are the secondary containers that you can hand carry to put the bottles in. And of course, label the chemicals as completely as possible, because accident can happen during the transport of chemicals too. So this is one of our elevators. If you are using the elevator, we have this sign and we block the entrance with the chain, and this is the sign says danger, chemical transport in process. And also you can have like people at the different levels of the building while the process is done. Sometimes you have to use the stairs. So in case if the elevator is broken, or in case the elevator cannot be used for the transport of the chemicals, have the stairways blocked, like have a personnel at the stair beginning and at the end of the stairway saying that there is some kind of chemical transport taking place until the process is done. All right. Now I briefly talk about the class which I teach. So it's Safe Chemical Laboratory Practices, which is offered in every fall. And it is mandatory for all the chemistry first year students, chemistry first year graduate students. And we welcome undergraduate research students and any other students who are interested. As of now, it is only offered in fall, but depending on the demand, we may offer it in spring as well. And these are the topics which I cover there: laboratory culture and EHS system, emergency planning, evaluating hazards, management of chemicals, working with chemicals, management of waste, laboratory equipment, laboratory facilities and PPE, and government regulations. And this is how the type of training we give throughout the course and how they are evaluated. So before they begin the class, I will give a preliminary test, because there's a departmental requirement to see their progress after 1 year after taking this course. So I give the same test the next year to evaluate them whether they have progressed. And then EHS helps us with fire extinguisher training. And they require to write a laboratory safety related paper based on an accident in the last 5 years, which involved a chemical spill or an accident in a laboratory. And they should be turning in the lab notebook, not the lab notebook, the notebook from the class at the end of the semester, so that I can go through that and make sure that they have all the proper lecture notes and all the contents from the class are in their notebook. And at the end of, so once I'm done with teaching, we take a week to do, we go around in batches, like I'll take 2-3 people, I'll ask them to sign up in groups, and we go around, we pick a couple of labs, like I pick the most chaos labs so that they have the violations so that they can go, this is not like an exam. I'll go around with them, then I go around to see what are there, and we have a checklist. I provide it to the students, and they go around the lab and do the checklist. They are welcome to talk to them, like talk among their peers and ask questions from me. The main purpose is to learn, not like an exam based on the things you learned in the course. And then finally, they'll take a final exam, which will determine their grade. Yeah.
People talk with like about code numbering, of course, so they get grants credit as well.
I don't know whether the department has communicated previously. This is the first time I just taught in last fall. So that's one thing. Yeah. That's one thing I consider. Yeah.
I have taken that. Long time. Another instructor, you were not.
Yeah.
And I think one relevant accident about transferring that liquid nitrogen from the elevator. So I don't know where it happened, but I can tell the story because the elevator, the car and the liquid nitrogen was going, but the elevator was kind of out of order.
Oh.
And accidentally, what happened? The liquid nitrogen started boiling up, and the oxygen was replaced as person died. And in physics department, what we do, we are transferring this liquid nitrogen from thread elevator, not from that elevator. So this is kind of chemistry does have thread elevator or not. I have seen two elevators. But, do you have the material transferring elevator?
We have one, but we use, I mean, maybe that's something that the department can pay attention to. We use it for normal use as well.
Yes, sir. That way you are blocking the human being also to use that elevator, but thread elevator should be more useful to transfer these gases.
I was curious about are you integrating the same curriculum to undergrad classes as well? If I'm a junior undergrad, and I take Chem 1, Chem 2, analysis, organic chemistry, and I made it all the way to organic chemistry 5. I was wondering, if earlier courses that you had
So you're not, I mean, for example, undergraduate takes my class. So I mean, although it's like an upper level class, the material covered is not that hard. So I mean, I had an undergrad who took my class last semester. So you're welcome to take it. That's what, I mean, good point. I mean, I can talk to the other instructors and ask them to like talk more little on this aspect in their classes, like the Chem 1, Chem 2, Gen Chem. Yeah, definitely let them know. Yep. Thanks for the feedback. All right, that's all I have for you. Any questions?
All right, with that, let's give Sadish a round of applause.